Hello and welcome to the lesson on how much energy do we use. So in the previous one we were looking at water consumption or water usage. Now we're looking at electrical energy. So I can determine weekly energy usage using a variety of math skills. So what I'm doing is providing you methods to analyze the cost and how much energy you're actually consuming. So as we look at the note here, energy refers to the use of electricity. So when I talk about energy, specifically in this unit, I'm looking at electricity, and we're looking at it and how it's used in our homes, our appliances, technology, lights, etc. So I can't tell you how important it is to realize how expensive electricity or energy is in order for us to survive. If you look at all the stuff that depends on electricity, there is quite a significant amount of technology in your home and necessary appliances, fridges, freezers, air conditioning, and so on. So let's look at a couple of examples. So by installing a new furnace, you use 35% less energy. So answer the following. The old furnace used 0.8 kilowatts of energy. Determine how much less energy the new furnace uses. So remember, when we're calculating using percentages, we take our percent, 35%, and we convert it to a decimal, so 0.35. So we're using 35% less energy. So we started with 0.8. We want to know what 35% of that is. So that's where that conversion to a decimal comes into play. So 0.8 times the 0.35, we get 0.28, and it was in kilowatt hours. So therefore, our new furnace will use 0.28 kilowatt hours less of energy. All right. Now that's a daily usage there. So the cost of energy is, in this example, 0.09 cents per kilowatt hour. Determine how much less money it would take to use the new furnace. So our old furnace, the one that we just replaced, used 0.8 kilowatt hours. If those kilowatt hours are costing us 0.09 per kilowatt hour, so we're multiplying that together, we end up with the 0.8 multiplied by 0.09. So we are looking at 0.072, and I'm doing this per day, just so you get a feel for the daily usage. Our new furnace is going to use, and maybe I'll add that to the note up here. So it used 0.8, now we're going to use 0.28 less. So when we do that calculation, it's now going to use 0.52 kilowatts per hour. All right, you can really do the calculation down below. So now 0.52 kilowatts hours multiplied by 0.09 kilowatts per hour. So now that's going to cost us 0.09. Gets us to 0.047 cents a day. Now what are we looking at over a year? So what's the cost over a year? So there's 365 days in the year. So if we make that calculation, just to compare it on a yearly basis, and you can understand why Mom or Dad says you got to turn off the lights when you leave the room and so on and so forth. That means that the furnace, just to run the furnace fan really, for our old furnace was $26.28. For the new furnace, it's costing us $17.16. So you end up with 26.28 minus 17.16. So you're looking at $9.16 savings each year. Okay, so I went a little beyond what the question was asking. Actually, no, that's what the question was asking, so I did exactly what I needed to do. So it costs, therefore, it costs $9.16 less each year. So now you're thinking, well, you're only talking $10. How significant is that? Well, that's only one appliance in your house. If you think of it, the furnace is just one appliance. We have fridges, we have microwaves, we have ovens, and so on and so forth. So when you start adding up the appliances, $10 on each appliance sure makes a huge difference. So let's talk about light bulbs for a second. So there are currently 2 light bulbs out there. There's incandescent. So the incandescent ones are kind of have this shape to them. And they are phasing them out. All right, we're no longer going to have those eventually. I forget what the target date is, 2016 maybe. However, those are being phased out, and we're getting the compact fluorescent, and those are the twisty ones, which I have no prayer in drawing properly. So something like that. And I don't know how to make it 3D, something like that. So that's what the twisty ones look like. That's a terrible twisty bulb, but anyway, you have the idea. So the CFLs are much, much more efficient. They use different amounts of energy. So for example, common household wattages, if you use a 100-watt bulb in the house, it lasts 1,000 hours. To get the same amount of light, you would use a 25-watt CFL, and those twisty lights are actually rated for 10,000 hours. Okay? If you want a brighter light, you'd have to go to a 120-watt bulb. With the CFLs, they're about 30 watts, and they still last the 10,000 hours. So what's the catch? Well, if we look down at the comparison here, you'll see what the catch is. So the average incandescent bulb, this might be a little bit out of dated now, but it costs about 40 cents per bulb. So the old bulbs that you probably see in the houses, the older ones, it's about 40 cents a bulb. To buy those new incandescent, or the CFLs, you're looking at $15 to $20 per bulb. All right, so you're thinking, well, that's probably why we shouldn't, or we don't use them as much, because they're much, much more expensive, which is partially true. But if we look at a comparison here, so we look at the incandescent for a second. So if we want to last 10,000 hours, so for 10,000 hours, that means we would need to get 10 bulbs. All right, so 10,000 hours, we need to get 10 bulbs. So therefore, 10 bulbs times 0.4 is going to equal $4. So $4 in bulbs. For the CFL bulbs, CFL for 10,000 hours, it's going to equal 1 bulb. So therefore, it will cost us, and probably for the 100-watt ones, we're only looking at $15. They are the cheaper. Actually, the price has probably dropped significantly, especially if this is past 2013. The bulbs are coming down in price. So let's talk about the cost to operate these bulbs. So if we want to go to 10,000 hours, we need to figure out how many kilowatts they use. So let's use the 100 bulb as an example. So the 100-watt bulb as an example. So 100 watts is actually equal to 0.1 kilowatts. All right, so I just made the conversion. So I just divided by 1,000. So that moves me from watts to kilowatts. Now I'm going to run these bulbs. So 0.1 kilowatts multiplied by 10,000 hours. So the 0.1 and times our 10,000 means that it will require 1,000 kilowatts to run these bulbs, or sorry, kilowatt hours. All right, so it's going to cost that. Sorry, it'll take that. So our final step, so if I do this in steps for you, 1, 2, and 3, that means that I'm going to take those 1,000 kilowatt hours that it takes to power the bulbs, multiply it by the cost, 0.08 per kilowatt hour, and our final cost then is $80. So 10,000 hours roughly translates to 5 to 7 years of use for the average bulb. So therefore, it cost us $4 to buy, $80 to run. So that means it cost us $84 for 10,000 hours. Alright, so that's your incandescent. Those are the older style bulbs. So let's do the same process here, except let's do it for the CFL. So similar steps. So up here it said that we need a 25 watt incandescent bulb to give you the same brightness. So step one is to figure out how many kilowatts that takes. So it's going to be 0.025. Oh, I'm jumping the gun there, sorry. 25 watts is equal to 0.025 kilowatts. And same thing, I divided by 1,000. Okay, step two, that 0.025 kilowatts, we're going to multiply by the 10,000. 1, 2, 3 hours. So 0.025 times the 10, 1, 2, 3, oops, 10,000. So that will take 250 kilowatt hours. Final step then is to take our kilowatt hours, so 250 kilowatt hours, multiplied by the cost, 0.08 per kilowatt hour. That means the cost to run these light bulbs for the same amount of time is going to be $20. So how much did the CFL cost us? Well, purchase price we said was $15. It's going to take $20 to run it for 10,000 hours. So final cost here is $35. So even if the bulb was actually $20, you're still well under half the cost to run the incandescents. So therefore, CFL bulbs cost half of the old incandescents. Save or cost half the old bulbs. So when you're looking at purchasing new bulbs for your house, you need to consider, yes, you're paying a lot more up front, but in the end, when you look at it, $84 versus $35 to $45 in savings. And when you're talking about how many bulbs in a house, the average house probably runs around 50 bulbs. So if you multiply your savings by 50, and for this example even, so say $40 in savings times 50, you would save $2,000 over a 5-year period for 10,000 hours of light. So it does add up in the end. So it's something you need to be very aware of, especially when you purchase your own house or you rent an apartment. You can save with electricity by putting proper bulbs in there. So that's why we're moving that way. So yes, the cost is loaded up front. It does cost more to buy them, but running them saves you a lot of money in the long run. So there you are.